This is the one sample z-test for our population proportion. So we use this if we want to know the value of our population proportion P of successes. We do have conditions. We have to check that n times this P0. Now, you might wonder what that P0 is. That is our hypothesized proportion right here. So if you're saying something like, we think our population proportion is 0.3, that P0 would be the 0.3. So we have to check that n times our hypothesized proportion is at least 10, and n times 1 minus our hypothesized proportion is at least 10. Our null hypothesis will be that P equals some value. Our test statistic is Z equals, we'll do our P hat minus our hypothesized proportion over square root of our hypothesized proportion times 1 minus hypothesized proportion over n. Then our p-values will just be the same thing we've been doing for every test. If we're looking for the probability that p is greater than some number, we'll look for the right tail. The p-value will be the area in the right tail. If we want the p is less than some number, we'll look for the p-value in the left tail. And if p is not equal to some number, we'll look for the area in both tails. Okay, this will show you how to do it in your calculator. Note that both of these require you to enter x, which is the number of successes, instead of p hat. It's just the way they programmed these two specific calculators. Some want p hat, some want x, the number of successes. Also, again, anytime we use our normal distribution with proportions, it's possible to use a continuity correction to be slightly more accurate. We're not doing that in this class, but some software does it automatically. So if your p-value is just a little different from ours, that's probably why. You probably have a calculator that does it. Let's try an example. A company that makes cheese spread is considering a new spout design. They won't use the new design if more than 5 people stop buying it. They took a sample of 1,000 people. 63 said they would stop buying it. Let's conduct a hypothesis test to see if more than 5% of all the consumers would stop buying it. Okay, it didn't tell me alpha. Let's use alpha equals 0.05. We need our hypotheses, null and alternative. So they want to see if more than 5% will stop buying it. So I would look for P greater than 0.05. Oh, it says here more than 5% too. That means then my null would have to be P equals 0.05, because your null is always in equals and the alternative is kind of what you're hoping to show. Okay, this means that P naught equals 0.05, or that's my hypothesized p-value. That's important because for your conditions, you have to check n times your hypothesized proportion is at least 10. So n equals 1,000 would be 1,000 times our hypothesized proportion. And this gives me 50. Notice this is not actually equal to the number of successes because we're not doing it off our sample, we're doing it off our hypothesized proportion, which is the 0.05. But that's at least 10, so that's big. And n times 1 minus p naught equals 1,000 times 1 minus 0.05, or 950. Well, that's bigger than 10 as well, so our conditions are met. For our test statistic, at this point, we're just going to pull up our calculator. Okay, I'm going to go to my stat menu. Test, I'm looking for something that sounds like proportion and z's. So here we have a one sample proportion z-test. My hypothesized proportion, that p0 is 0.05. X, our actual number of successes, is 63. So n equals 1,000, x equals 63. N equals 1,000. Let's see, you need to choose your alternative. We have a greater than. So select greater than, and we'll go down and calculate it. So it looks like my test statistic is z equals 1.88. If I was to draw this, here is my 1.88. This is a greater than, so I'm going to shade to the right. And this is finally the first time in the class I've done an example on the calculator where my p-value is big enough you can actually see how they shaded it on the calculator when you do draw. That's what it's supposed to be. It's just every time it's been so small you can't see. My p-value looks like is 0.0296. Well, that is a small p-value because it's smaller than 0.05. So we always compare it to alpha. So I will reject my null. And that means we have evidence that the proportion of all customers who would stop buying the spout is greater than 5%.